Hey everyone, today we're going to be looking at graphing. If we're going to do an experiment and we're going to make a data table and we're going to fill in the data table and we're going to get just piles and piles of numbers and we're going to work those numbers and figure out the mean and do all the data analysis, it only makes sense that we try to communicate that data clearly. And looking at a page full of numbers, I know as someone who used to do it and sit and I take all my data and be like, what does this mean? It's so much easier to make sense out of it by making a graph. And so today we're going to look at graphing and why it's important and different types of graphs. I know you've used these in the past in sixth grade science and probably in elementary school. So this should be a little bit of a review, but we want to make sure you know. So in science, graphs are used to analyze data to help us understand and recognize trends and patterns. Um, and we can look at a lot of information in a short amount of time. The two most common types are bar graphs and line graphs. There's also pie graphs when we're dealing with percentages. In seventh grade science, we don't really look at a lot of pie graphs. So today we're going to be focusing on bar graphs and line graphs. Let's start with bar graphs. Bar graphs are used to compare things in different groups. Um, Oftentimes, if you are looking at a snapshot in time, looking at this compared to that. Um, and so when you are counting things, often it will be best looking like we're looking at a bar graph type situation. Um, Bar graphs are going to give you totals. Uh, the other type of graph that we're going to look at is line graphs. Line graphs are when the data you're looking at is changing over time. Um, so we're connecting. You're going to set up everything just like a bar graph, but from one point to the next point, the data is changing. And so the reason we draw the line is to show that it isn't just separate events, it's one continuous thing where the data is changing. And the thing that always gives away when it is supposed to be a line graph is that on the x-axis, we have some unit of time. Over here on the right, we have hours, or on the left, we have days, but it's showing that over those periods of time, things have changed. So, what do our graphs need if we're going to have them be effective? Well, we need a title, we need to label the x-axis, we need to label the y-axis, we need a number scale that shows what do the numbers mean, and of course we need to put our data on there. So we're going to compare this to building a house, and to do that, we're going to make up a fake experiment, and so we can take a data table and look and put this together in a graph. So our experiment is, does the type of fertilizer affect the number of seeds a pumpkin has? As I said, we're going to compare making a graph to building a house. Um, I don't know if you've ever built a house before. Maybe your family has had that process happen and it's complicated. But the first step of building a house isn't hanging pictures on the wall or painting. You've got stuff to do first, some basic ground level things. And so we're going to have an order. The reason that we like to teach doing a graph in a set order, you won't forget a step. And that's kind of important. So let's look at our data. Again, we have a data table, and on the left, we have, let's focus on that. So over here, top left is always going to be our independent variable. So this is what we were comparing. We were comparing the type of fertilizer, and we had 4 types, A, B, C, and D. On the top right, we had the number of seeds. So earlier in the year when I said, hey, you really need to set up your data tables the same every way, you'll see why this was the case. So our number of seeds that our data that we found, type A had 100, B had 280, C 270, and D 400. So this was the data we collected. That's what we're measuring, and this is what we were comparing. All right. So the first thing that we need to set up in our graph is going to be the foundation or the floor. So we're going to start on the bottom of the graph. And on the bottom, we're going to put our independent variable. So we can always go back. This right here, what's in the top left corner, is always going to go onto the bottom of our graph because that's what we're comparing. And you can see, okay, well, in general, I'm looking at types of fertilizer. We're telling the person reading our graph, this is what we were comparing. And we then list, well, we had 4 different types, and we put that across the bottom. That's step 1. The next thing that we need to do is start building the walls. So if we're going to start on the bottom with the x-axis, then we need to move over to the y-axis. And on the y-axis, we have a couple different things we need to do. One, we need to label what are we measuring. That's our dependent variable. So again, back to our data table, we had our dependent variable was number of seeds. And that's going to go right here every time. Whatever we have as our dependent variable will go on our y-axis. Now in this case, our units would be seeds because we're counting. If you were doing some type of metric measurement, like measuring in degrees Celsius, then you would have to put the units of Celsius on there. Or if you were measuring volume, and you might need to write milliliters or something like that. The second thing we need to do is we need to put these numbers on here. So we have to look at our data, going back, and we go, well, our data can go from 100 to 400, and then we go back over to our graph. That means we have to get to at least 400. Actually, I would like to be a little bit above that so it doesn't look like our data is exploding off the top of the graph. And we also have to make sure we understand what would be the smallest point we could put. And we're talking about number of seeds that a pumpkin could have. And I guess it's possible that a pumpkin could have 0 seeds. So a lot of the time, it makes sense that our dependent variable on the y-axis, when we number that scale, usually it will start at 0. All right, so we've got a floor and we've got walls. Couple things to point out. Be careful that you have enough room on your graph. You can't just change how many lines you're putting on. So in this graph that I'm looking at here, the highest data point was 12. I like how this was set up. So we set up our scale to go to 14. So we're using up most of the space. You don't want all of your graph sitting down at the very bottom. It wouldn't make sense on the graph on this screen to number up to 1,000. I mean, you would have all of your bars way, way, way down, way at the bottom. It's like whispering your data. No whispering data. Tell the world, people, this is what I did. This is my data. Don't hide it all in the corner. Spread it out. Use up the whole space. All right. Next thing we need to know is we need to put a roof. You've got a floor, you've got walls. We need to cover this up. We need to put a roof. Give yourself an informative title. The title goes on top. I generally, when people ask me, hey, Mr. Berg, what do we need to do? Like, what makes a good title? Think about what your question was. List the independent and the dependent variable. So here we've actually just written the question. Does the type of fertilizer affect the number of seeds a pumpkin has? You don't have to list it as a question. You could just say the effect of fertilizer on the number of pumpkin seeds. But put what the graph is about. Don't just write pumpkins. Don't just write fertilizer. Don't just write my test. Give us some information about what this graph is about so anybody who reads it will be able to figure out what's happening. All right, next we need to look at, does the type of fertilizer affect the number of seeds the pumpkin has? Well, great, but they're never going to know if you don't fill in the graph. So here we have to choose what type of graph are we doing. And because we're looking at 4 separate types of fertilizer, these are not time. We're not looking at a change over time. So we're looking at a bar graph. And so now it's time to decorate. Fill in all of the graph and make it nice and neat so that anyone who's reading it will be able to look across and see, hey, this is what we're doing. So again, label the x-axis, label the y-axis, make sure you have a good scale. Do you use most of the space? Do you have a title that tells what you're actually doing? And then did you put in all of your data correctly? That's what we're looking for to make a good graph. Tomorrow we're going to get to do some practice in reading graphs, and then next week we're going to start making some graphs. So if you have questions, let me know. Otherwise, good luck and make some graphs.